Welcome to the Lesson 7 homework instructional video. So if you're in your Lesson 7 turn-in homework, everything is going to be on this one file. I will open up the PDF as usual. So important instructions here. Be sure you round any probabilities to 4 decimal places. Use complete sentences when you're asked for it, and don't forget units anytime that is relevant. So the first question is asking about the weights of NFL players with this is not using the central limit theorem yet. So sketch the distribution for your random variable X, which is the weight of an individual football player. Be sure the mean and standard deviation are labeled. Use that distribution. So you're going to use your image to then sketch the area associated with the probability a player weighs over 250 pounds, and then show how you calculated it below. So normal CDF, or if you use an online resource, tell me the values that you've entered and tell me that you're using the online resource. Now we have a sample of 53 players. Sometimes students want to then do the central limit theorem for the sums. Don't do sums, do the average. So X bar is the average weight of 53 NFL players. So what changes about our distribution and why does it change? Be sure you reference the central limit theorem. The criteria of the central limit theorem tell us what this new distribution will look like. And then find the probability a team of 53 players weighs over 13,250 pounds total, which means they average 250. So just like here, we're looking for X being 250. Now we're looking for X bar being 250. Don't use 13,250. That's the total. This random variable that we sketched is the average. And then finally, this is kind of interpreting that probability. You get a probability here, and then I want you to interpret in the context, would you feel comfortable flying on that plane with the probability that you've calculated? Question 2, I want you to describe very clearly what does our random variable p hat represent. So in the full context of the question, what does p hat look like as a random variable, the distribution, again, using the central limit theorem. Show me where mean and standard deviation come from. Find the probability 89 or fewer in our sample has gone skiing before. Note that this is a number of successes where this is proportion. So you need to convert 89 into a proportion. Note your sample is 120. It is not 100. Do not think 89 is 89%, please. So find that area on your distribution, shade it as above, and then do the calculation, some normal CDF below. This is now going to be an inverse norm question, bottom 10%. And once again, when you have your answer, you will find a p hat value, and then you need to convert that p hat value to a number of successes. Sort of like here, we did a number of successes converted to a p hat value. This time you're going backwards. This question is a little bit trickier for that reason. It's got an extra step that you need to do in your calculations. Here's another example with a proportion. Interpret it. What does it look like? You don't need to draw the distribution this time. Find that probability. Just describe what happens to the distribution. You can use calculations. You can simply just argue what happens when we increase our sample size to the distribution. And finally, find the probability if we took 10 randomly selected female students, their mean height is between 62 and 65 inches. And what happens if we instead just record the height of one female? You can either do the calculation to answer your question, or if you can explain it logically based on the differences between these distributions, that is also acceptable. All right, let me know if you have questions. Have fun.